Hey folks, welcome back. This is Joel, and in this video we'll be actually looking into another interesting protocol, the OSPF, right? Um, yeah, so these are some of the interesting features which we'll be looking into. We'll be talking about the basic configurations, looking into the Ethernet or as well as the point-to-point kind of setup. We will also look into the authentication piece of it, LSA types, right? Type 1, type 2, type 3, you have till type 8. So we'll look into all those things. We will look into the multi-area, right? Summarization, filtering, and redistribution as well. The various area types, right? Stubs, NSAs, etc. And we'll also talk about the virtual links, right? A very simple topology to learn to begin with, right? So so you can see here there are various segments in the network. So we have like Ethernet segment, and we have the serial segment over here, right? So these are the serial interfaces, the yellow ones, and the blue ones are basically your Ethernet segments. All right. So the Ethernet segments has kind of like four networks or four segments inside it. Like for example, you have the dot 100, dot 200, you have then the dot 67 and dot 78, right? So there are four separate segments, whereas the serial has a couple of them, dot 25 and dot 45. Right now, OSPF is the only protocol that works differently based on the media it is running over, right? So if it is configured to run over the Ethernet, which is this segment, right, this piece of it, so if it is configured to run here, it will elect a designated router for the network. All routers in that particular segment will establish a neighbor relationship towards the DR or designated router to cut down the number of neighbor relationships it needs to maintain, right? So for example, this particular segment, which involves R1, R2, R3 present in 192.1.100, so these three routers, right, they form one particular segment, right? So and they will form, or they will elect a designated router, right? Why do we do that? Because else what has to happen is that R2 will have to form neighborship with R1 and R3. R3 will have to form between R2 and R1, and similar is the case with R1. So it would create a lot of neighborship churn, right? So that's why what we do is we create one guy as the designated router. Let's assume R1 becomes a designated router, and the rest of the guys basically end up just forming neighborship only with him, right? And he will then distribute the routes to the rest of the routers in the network. All right. Now if it's a configured to run a P2P or a serial kind of a setup, right, like here, so it knows, or OSPF knows, that there is only one neighbor, right, on this segment. Like for example, here between R2 and R5, it knows that there is only one neighbor in this segment. So it will not run any kind of election for a designated router. It will straight away set up a neighborship with the other router on that segment, right? So and the other thing is that the number of designated routers in the area will depend obviously on the Ethernet, the multi-access segments you have, right? So like for example, let's assume this whole network is in area 0, right? And how many multi-access segments do we have? So we have one segment over here, the other one is here, dot 200, then dot 67 and dot 78. So we will have 1, 2, 3, 4 designated routers in this kind of a setup, right? Now let's look into some of the things on the router. There are two different types of interfaces here, and like I said, OSPF behaves differently based on the media, right? So let me show you what I was actually talking about. So if I do show interface Ethernet 0/0, you can see that the encapsulation here is ARPA, right, over here. So that basically means that it's a broadcast multi-access kind of a segment, right? Broadcast multi-access is basically the Ethernet segment, right? Whereas similarly, if I see the other interface, so you see there is another interface which is the serial interface here, right, which is serial 1/0. So if I do show interface serial 1/0, you will see that the encapsulation is HDLC, right? So OSPF is able to figure this out. It looks at the encapsulation, and it kind of behaves differently based on this, right? So on the same router R2, right, so along the interface Ethernet 0/0, it behaves as a broadcast multi-access, which will involve all the election of the designated router, backup designated router, and so on. Whereas on the other side, which is segment serial interface 1/0, it behaves like a point-to-point, point-to-point OSPF kind of a setup, right? So let's go ahead and do a little more, right? Start configuring a bit so that we get more familiar with this. So let's start with the Ethernet segment, right? So how does it actually behave? Let's talk a little more on that. Now let's go into probably router 1 and start configuring as well, right? Let's go down to probably router 1, and what do we do to do this? Let's do show IP route, and let's look into what is directly connected in my network, right? So you can see we have the 192.1.100, and the other loopback is basically 1.0, right, network. So how do I enable OSPF here? So if I have to just go to config router OSPF, the process ID is important. I can use anything, it's just locally significant, right? Then you need to define a router ID, right? The router ID is pretty interesting, right? So every router, OSPF router, in order to communicate, right, requires a unique identifier. So this will be like a router's name, so it is in the format of an IP address. So in this case, let's say I can put something like this. So the format is just like how you define an IP address. It's not an IP address, right? So this just use it to identify, right? If you don't specify a router ID, what happens? It will just pick up the highest loopback address. If there is no loopback IP, it will pick the highest IP address on any interface on the router. That's the that's the rule, or that's basically how OSPF operates. Now let's go and enable it for the networks 192.100.0 for this network, right? Mask is going to be wildcard, right? So you go with .255, area is important, and we say 0. Similarly, network .0, and the mask being because it is /8, right? Give me a minute. Yeah, so so I could probably, because it's /8, so I could go with this, right? It's good. So that's basically how you would enable it on basically router 1. So you just define a process ID, the router ID, and then you advertise it, or basically, my bad, you enable it on the network, right? So it's 192.100.0, so that's the network, and then the mask being, because it is /24, so use this wildcard mask, and because it is /8, right, you define the IP address, and the /8 basically is the wildcard mask over here, right? But now you need to do the same thing on my router 2. So let's clear this. In order to configure on R2, let's go inside and do show IP route. Let's see the connected networks. Once I do that, I can now run configure router OSPF1. This is the process ID. Router ID is important. We will see how it is used for the election later. Networks, which network? So we will start with advertising this one, right? 0.255. Let's say the area 0, and the other network being this one, which is 0.255.255.0, area 0. I think I made a mistake. Yeah, area 0. Right, that's good. Now you can see already the OSPF neighborship has come up, right? So how do you check what is the state of the, you can see show IP OSPF neighbor. So you can see it has R2 has established neighborship with this router, and the state of that router is DR. So what is the state of my router, which is R2, which will be show IP OSPF interface Ethernet 0/0, I believe. right, will tell me that this is my current router ID and my current state is BDR, right. So in my segment, what has happened is that R1 and R2, between R1 and R2, R1 has been elected as my designated router, right, and R2 has become the backup designated router. So let's actually talk a little bit about this election. How did it happen? So for DR election, or the designated router election, when the router on the segment comes up, right, it will check to see if there is an existing DR on the network. So if it sees a designated router and a backup designated router on the network, then it establishes neighborship with them and exchanges the routes. Now if it is the first router on the segment, so in this case R1 was the first router on the segment, wasn't it, right? So R1 was the first router on the segment. So it will wait for 40 seconds before it will start the election, giving time to other routers to come up, right? As soon as the 40 seconds expires, the first router starts an election process, and any router in that segment that is up at that point of time will participate in the election, right? Now what happened in my case was I enabled router OSPF on R1, then obviously after 40 seconds I enabled it on R2. So as a result of that, R1 basically came up, it did not see any other router, and as a result of that it declared itself to be the designated router, and that's why R1 became the designated router. Now when R2 came up, it already saw that there was a designated router, so it kind of became the backup designated router, right? So the other interesting thing is router interface, priority, right? The priority during the election, right? During the election. So let's assume that the R2 router actually came up within 40 seconds of R1, right? In that case, there will actually be an election between these two routers. Now, what are the parameters which are used for the election? The first preference is always the interface priority, right? If the interface priority is higher, then that particular router will become your designated router. Now if the priorities are the same, in this case you can see both my interfaces have the default priority, right? You can see priority is 1 here as well as here. So if both the interfaces have the same priority, then the highest router ID wins the election, right? In this case, R1 is having a router ID of this one, whereas R2 has a router ID of so on. So the highest router ID would win the election, right? Provided your R2 router actually came up within 40 seconds of R1, which wasn't the case in my case, right? So the other interesting thing which I want to point out is that if another router, right, comes up after the election has taken place. So in this case, R2 actually came up after the election had taken place. Then though this particular router has a higher priority or a higher router ID, it will not force for an election, right? It will just establish neighborship with the existing DR and BDR. Okay, let's continue and configure on my R3. So now what is the current state? We on this segment R1 and R2 have already been elected as the DR and BDR. So let's just to prove my point, what I'll do is let me configure this R3 with the highest priority, but you will see that still the election won't take place, right? It will not force for an election. So show IP route, include connected, and configure router OSPF 1. Router ID is important, 0.0.3, and the networks, right? Well, actually before that, like I said, let me which interface are we talking about? So in R3 we are talking about the Ethernet 0/0, aren't we? So let's actually go to this Ethernet 0/0 and let me actually put a good priority, right? So it's going to be IP OSPF priority, probably I'm gonna put a priority of 10, right? Now let's go back to my router OSPF and let's continue enabling it for this network, right? And it's going to be 0.0.255 area 0, and the other one is this one, right? 0.255. There you go. That's it. Okay, so now it has already come up. So if you want to see what is the state of this, you can first do this OSPF neighbor. So you can see that these are the two neighborship it has formed. In this segment, your 0.1 is your DR and the .2 is your BDR. Right now, if I want to see show IP OSPF interface Ethernet 0/0, you will see that the state, right, though this guy has a higher priority, the state is basically DR other, right, which basically validates my point which I told earlier. Okay, the other point which I also want to bring out here is that when you say the concepts of DR and BDR, right, it is per interface or per segment, right, and it is not per router. So you can't say R1 is the router, R1 is the DR and R2 is the DR. So that's a wrong statement. You can say you can basically call it as a designated router for a particular segment, right? So in this case I can say R1, let's see who is the designated router. Yeah, so I can say R1, right? So R1 is the designated router for the segment 192.100.0 along this interface, right? Because let's say R3 is part of two networks or two segments. It is part of 192.100.0 along this, and it is part of 192.100.200 along this, right? So R3 might be a designated router along this segment, whereas it could be probably something else along this particular segment. So it's per segment or per interface, right? It's not it is not a router specific designation. So that's something which is interesting, right? What else? Some of the timers which are very interesting here. So if you look here, there are a lot of timers which are mentioned here. So let's just talk about that, right? First is your hello, right? Hello is basically the this is the interval at which your hello packets are basically sent out, right? It's sent out every 10 seconds. And dead time. So dead timer is basically tells us that it is going to wait for an hello until for like 40 seconds, right, until you pronounce your neighbor to be dead, right? So every 10 seconds you're sending your hellos, but let's say you did not get an hello, so you're going to wait for 40 seconds, right, until you pronounce your neighbor to be a dead person, right? So dead router. The other one is the wait interval. So this wait interval is basically that interval which I talked about earlier, where the router is going to, when it comes up the first time, right, initially is going to wait for 40 seconds before it can begin the election, right, for a particular segment. So that's your wait interval. Retransmit, it basically it is going to wait for 5 seconds before I retransmit an update, right, because of no acknowledgement. In case of OSPF, you send some update and there is acknowledgement, but if there is no acknowledgement from the other side, then you're going to send another update after waiting for 5 seconds. So that's some of the timers. Now the interesting piece is, let's talk about what if our designated router goes down, right? So we have R1, R2, R3. R1 is a designated router now. So what if designated router goes down, then what happens? So in case of that, the backup designated router takes over, right? It will wait for obviously 40 seconds to pronounce your designated router as dead, right? Then your backup designated router becomes the DR, right? Now once that happens, right, then there will be obviously an election to elect the new BDR, right, because the BDR became the DR. So the position for, or there is a vacant position for the BDR, so there will be an election for that. We could actually see how this happens. So we will go down to my R1 and let's actually what we'll do is we'll go to interface Ethernet 0/0. So for this interface, let's shut this interface down, right? So once you shut this interface down, you can see here right, so you can see that my this thing still stays that give it some time. So you can see the logs here which says the interface went down, shut down. Did I do it on the right interface? Yeah, so you can see the neighborship has gone down, which is good. So which is, yeah, so you can see now it is pronounced as dead, not yet. So you can see now it is completely removed, right? Let me clear the interface a bit. Now R2 was my BDR earlier, wasn't it? Let's see what is the state of my R2 now. Show IP OSPF interface 0/0, right? So you can see the R2 has actually been promoted as the DR now, right? And an election was held, and as a result of that, you can see R3 would have become the BDR, right? Let's see that. So if you do show IP OSPF interface Ethernet 0/0, you can see that my R3 has become the BDR, right? So it basically validates my point. Okay, now if you bring back the R1 up, do you think R1 will again become the DR? No, it won't, because as I said, if in a segment you already have DR and BDR, then there won't be an election forced, right? So let me do no shut. Okay, so I did a no shut, and you can see show IP OSPF interface Ethernet 0/0, right? So the state has become DR other, right? Got it? So it has not forced himself to be a DR or BDR. So that's basically what I wanted to show here. The next piece, let's continue enabling my OSPF on the other segments, which is .200, .67, .78. Okay, so okay, so let's do that. So we will start with R3, right, because we have to advertise R3 in this 200 segment, which I did not do. We will go down here to add my R3. So yeah, let's clear the router a bit. Show IP route, see my connected networks. Okay, so let's continue router OSPF 1, and sorry, yeah, correct, network is this network is something which I want to advertise. 0.0.0.255, and which area? Area 0. Good. You can see the state of this as well. Show IP OSPF internet, it's going to be internet 0/1 if I'm not wrong, right? So you can see the state is waiting. So this is the state I was talking about, the first 40 seconds. It's going to wait for the first 40 seconds before it can actually, start an election. So this is that initial, state, right? So now after 40 seconds it is going to obviously call himself to be the designated router. Is the 40 seconds done? Yeah, so after 40 seconds it is going to start the election, and because R3 is the only router in the segment, it has elected himself to be the designated router, right? Cool. What else? So now let's go and enable it on R4. Right. So let's go out here, router OSPF 1, router ID .4, networks. This 200 network is what we are talking about now. The other one is the 4 network. There you go. So enable it on 4. Obviously when it comes up, because R3 is already the designated router, R4 is going to be the backup designated router, right? Show IP OSPF interface Ethernet for R4, which is the interface. So we are talking 0/0, right? So head over 0/0, you can see it's going to be the backup designated router, which is correct. Cool. Moving on, let's enable it on R6 and R7 for the other segment, right? So let's clear the screen a bit. R6, give me a second. Sorry, R6 is still part of this, right? So I did not do that. Let's do that. Show IP route. Right, so if you see here, what I intend to do is router OSPF1, router ID is your 0.0.6, and the network is this one, right? 0.0.0 and area 0, right? So this is the whole .200 network is done now, right? And you have the DR, BDR and everything set up, right? So I can anytime do show IP OSPF neighbors, so you will get to know that R3 is your DR and R4 is the BDR for that segment. Cool. Now what I want to show you guys is the actual election process, right? The whole fighting and figuring out who will become the designated router and so on. So what do I need to do? I need to enable both the networks within 40 seconds so that we can actually see the election happening. So what I'm going to do that is I'm going to do that between my R6 and R7, right? So let's do this. So we will go down to config mode, right? We have to enable it for the 67 network, right? So let's do router OSPF1, right? Router OSPF1 and network. What I'll do is this one here, and the other side is sorry. Okay, so that's good. Now I'm not going to hit the enter. Did I do router ID? I think router ID is there. Okay, I'm not going to hit the enter here. Let's actually go to R7 and also prepare the config and keep, so that I just want to enable both of them within 40 seconds, right? So to show IP route, router OSPF1, router ID is 00.7, and the network, which is which network? So we gotta do this. Area 0, right? So we have both these guys. So now I'm gonna hit the enter on my R6 and gonna hit the enter on my R7, right? Probably also put in the loopback address, which I did not, would be 6.0. And here it's gonna be just 7. Right? So now the election is happening, which means you will see if I go to this interface, it's to show IP OSPF interface 0/0, right? The election has taken place, and sorry, it's not 0/0, /1. So the election has taken place, right? And you see that between R6 and R7, right, R6 has become the BDR, right? Because R6 and R7 we enabled OSPF within 40 seconds, so there was an actual election, and the priority of both the interfaces was 1, right? So let me show you here on my R7. If you see, the interface is 0/0. So if I clear the screen a bit, right? So if you see here, R7 has become the DR, whereas R6 has become the BDR. Where is R6? You can see here. The reason is because R6 has a lower router ID. It is 0.0.6, whereas R7 has a higher router ID, right? So as a result, it took precedence, and R7 was selected as the DR, whereas R6 became the BDR. Okay, makes sense? Great. So the last segment is your .78, right? So let's go and enable it for this as well. So I'm already inside the router, so it's basically going to be network 192.1.78.0 and 0.0.255 and area is going to be 0, right? Let's go to R8, enable show IP route what is connected, right? And configure router OSPF 1, router ID is important, 0.0.8. What else? Network, which is going to be my this one, sorry, 255, area 0, and the other one is network, just this one, right? 0.255, 255, and 255 areas. Make sense? Between R7 and R8, obviously I'm not sure if the election is over. Let's see, show IP OSPF interface Ethernet 0/0, right? It's still in the waiting state, right? The initial 40 seconds, but once that is done, we will have the election completed, and either R7 and R8. Between these two guys, clearly R8 will be the designated router because it has higher higher router ID, right? So that makes sense, right? So that's what we did. Some of the we basically ended up configuring. So we can also now look into so we are on the last router, right, of the segment. If we do show IP route, there you go, we have reachability to every single router in the network, 1 2 3 4 5 6 7, and 8. All of those networks are seen in my routing table, right, which is pretty good. Now very interesting thing which I want to show you guys is the loopback interface, right? Actually I can show you guys that on anywhere, right? You see here on all these routers, what you observe is that my loopback interface everywhere had a mask of /8, if I remember right? So everywhere, like if I go to R1 and if I let me clear the screen, right? So show IP route and include connected, you see my mask is 8, but when it was learned on the other router it became /32. So you can see on even on R8 it is learned as /32, right? Why is that? Because OSPF is intelligent enough to see that loopback interface as a loopback, as a dead point, right? It knows that this is not a real network but a dead end, like a host, and advertises it as /32. So OSPF is doing this work for you. So the neighboring router receives the update as /32. So if you want to receive it with the proper mask, then you need to go under every single loopback interface and change the network type, right? So if you see the network type now, show IP interface, show IP OSPF interface loopback 0, you can see the network type is currently going to be loopback, right? So we need to change that. So what we'll do now is, let's go into configure mode, and if I go to interface loopback 0 and if I change it to IP OSPF network point to point, right, and to do that, right? So once I do that, if I refresh it now, you can see clearly the one network is now learned correctly, right? You have the /8 when compared to /32 earlier, right? So you need to do that. I can do that probably on all my routers because I have loopbacks everywhere, right? So I can go to probably this place as well, loopback 0, probably put this, sorry, my bad, copied something wrong. This is what I want, right? This is what I want, put that. Let's clear on this as well. R3 is good. 4 is good, but you get the point, right? So that's exactly what we are trying to do here. Let me quickly do this and show you guys that for everything it would have changed now. Let me put this. That's good. R5 is good. Sorry, that is good. 6 is good. Let's do 7 and 8. There you go. So once I do that, I can probably clear the screen a bit, and you can see what was learned is that show IP route. Now everything has been switched to /8, right? It was /32 earlier, now it is /8. So that's something interesting, kind of very interesting to know about the loopback interfaces. Okay, great. What do we do next? The next is, we till now looked at the broadcast multi-access segment, which is this one, right, with the Ethernet. Now look at this. Now let's look at the serial interface, which is here, right, which is interesting. So let's go down to my R2, right, and let's enable it for the other network, right? So let's go to show IP route. What I mean is I need to do it on this interface, right? So if I do configure, what else, router OSPF 1, and just need to advertise this network 0.0.255 and area being 0. Okay, now I need to do the same thing. Like I've told you, we are trying to do the enabling of OSPF for the serial interfaces now, right, the point to point, right? So we did it on R2, and we will now, I can also show you that this one, right? So IP OSPF interface serial 1/0. So you can see here the network type is point to point. Network type is point to point. So that's the OSPF behaves differently here. So if I show you the same thing here for the Ethernet 0/0, it is different. It is broadcast multi-access, right? You can see here it is network type broadcast. So the Ethernet, on the Ethernet segment you will have OSPF behave this way, whereas on the point to point segment you will have it behave a different way. So we did it on R2 now. So there is no DR or BDR election or something here. So you can see there is nothing like BDR DR mentioned here. It will directly form neighborship with the router in the segment, right? So in this case I did it on my R2. I did it on my R2. I need to do it on my R5 as well, right? So let's go to my R5, router OSPF 1, and the network is basically that same network which I did it on my R2. I can probably copy it from here, right? It's gonna do it on, right? Okay, right? So once I do this, see the neighborship came up automatically, right? You don't have the concept of I can do this show IP OSPF neighbors. You can see on R5 you see you don't have any state mentioned, right? Even on my R2 I can do this show. Let me clear the screen a bit. IP OSPF neighbor. So you can see here for the other two segments you have DR BDR, whereas for the serial segment you don't have it, right? You just have it as full. Okay, also I believe I forgot to put in my router ID for R5. That's why you get it as like this, right? It has already picked up the highest it has picked up the IP address of the loopback interface. Okay, so that was how you do it on R5. So we did it for this segment. There's only one segment which is left, right? Let me actually go and put in the router ID because that could be useful for my later sections. So OSPF 1 and router ID is 0.0.5. Okay, so you need to clear it, otherwise it won't, right? Sorry. There you go. So now it's going to refresh and get my thing up again, which means if I refresh it here, you can see it is effective. Okay, great. So now let's enable it on the 45, which is my R5 and R4, right? So let's go to my R5, configure, OSPF1. The only network is that I need to enable it on 192 1.45, sorry, dot 0 255 area 0, also probably on the loop back. I believe I have not done that. There you go. So R5 is done. The other is the R4. I need to do it on R4, which is here. Just need to enable it. Just need to enable this particular network, right? This one. So let's go here. Router OSPF 1, and let's just do this. That's it, right? So it should all be good. Yeah, so you see the R5 and R4 serial interface, even that has come up. Just to confirm, you can do this show IP route. Yeah, so you have 1 2 3 4 and 5 6 7 8, so you have reachability to everywhere, right? Okay, this is the directly connected one, right? That's why it appears like this, whereas the rest of the guys, you know, you have or I could, yeah, that's good. Or if you want to just look at the OSPF routes, you can do that as well. So how you do that? Show IP route, just do OSPF and you get just the OSPF routes. So you can see 1 2 3 4 4 is not there because it's directly connected. 5 6 7 8, so you can see all of these guys coming up, right? You did not have 5 earlier, but now on even on my R8 I can just do, and you'll have the 5 because, you know, we have just enabled it. Yeah, there you go, 5 is coming here, 4 and 5 are coming here, which means the you know, OSPF has been enabled even on the point-to-find networks, right? So just to recap, on the point-to-find interface, there's only going to be a single neighbor, right? And because of this, OSPF does not do any DR BDR election like we did earlier. Okay, great. So the last part which I want to talk, you know, before we go to the next phase is the authentication part. So you can do two types of authentication. You can either do clear text or you can do MD5 or message digest authentication, right? For doing the clear text, we'll go to R1, right? And you just need to, you know, let's do it for this segment, right? The .100 segment. Okay. So interface Ethernet 0/0. What we do is we do IP OSPF authentication, enable that, and then we do IP OSPF authentication key, right? And define a key. Let me define Cisco as the key, right? So if I have to show you, it's going to be do show run or show interface. Okay, let me just Ethernet 0/0, right? So these are the two commands which you need to put in, right? So I'll have to put this on all my guys. I'll have to put this on my R2 as well. You can see because I put in that authentication, right? This particular neighbor went down, right? Now when I put this back on, oh my bad, I just need to put these both, right? So this is for clear text. We are directly sending the password, you know, via clear text. And even on R3, you see the neighbor has gone down. So I need to do this for Ethernet 0/0. R3, right? We're talking about R3. There you go. So once I do this, you know, all the neighbors should come up properly. Once again, show IP OSPF neighbor, right? So it has come up. 1 2, yeah, both of them have come up. So that's how you do the clear text authentication. Okay, now if you want to do message digest, right, let's do that between for the next segment, which is my R3, R4 and R6, right. For that segment, if I have to do, let me do that. So it's going to be 0/1 for my R3, so it's interface ethernet 0/1. What is the command? You do IP OSPF authentication and you say message digest, right. Then you do IP OSPF message digest key, put in a key, message digest, yeah, key is there, you put in key ID and MD5, right, and put in the password, let's say Cisco, right. So if I have to show you, it appears like this. If I do show run interface ethernet 0/1, right, these are the two commands. So this is how you do the message digest authentication. So obviously I need to do this on my R4, which is on 0/0, and R6 0/0 as well. Let me clear this /0, and that goes. Whereas let's do it on the R6 as well. Let me clear this, enable configure interface ethernet 0/0. Let's do it here as well. There you go. So we have done authentication now, right. Everything should come up, so you can see the neighbor coming up, show IP OSPF neighbor, right. So you can see, you know, R6 has connectivity to 3 and 4 and 7 on the other side. So yeah, so that's how you did it, right. So you basically enable, you can enable authentication either using clear text, or you can do message digest or message digest authentication as well, right. Great.